Hi dear students, in this video I'm going to explain the properties of the determinant. And here we are starting with the first property or theorem, we can say. Let A n be an n times n matrix, which means square matrix also. Dimensions are same. If the elements in any row or column are all zero, then determinant of the matrix A, it should be equal to 0. So here, as a matrix, I have written this matrix, and in this matrix, this row all completely they are equal to 0. And if you remember the cofactor expansion, if you are choosing the second row here as your reference as your reference row, here all the entries are 0, 0, which means that the formula with A21 times C21 plus, this is A21 if you remember, this is A22 and this is A23, it's going to be, plus A22 times C22 and plus A23 times C23 it was. This is the cofactor expansion of the matrix, and we are finding the determinant with this method we were finding. So I'm going to make here this is equal to 0 and this is also equal to 0 and this is also equal to 0. Multiplication 0 times C21, it's equal to 0, and this is equal to 0 and this is also equal to 0. So if they are all equal to 0, the sum also it's going to be equal to 0, which means that determinant of the matrix A, it should be equal to 0. Let's continue with the other properties and theorems. Again, the square matrix, if A has two identical rows or columns, then the determinant of A, it should be equal to 0. Or if A has two rows or columns which are multiples each other. Multiples of each other means, here, let's write the matrix B here, then we can say 2, 3, 1. And 3, 1, 8, and multiply by 2 the third row. These are identical, so let's say 4, 6, and 2. So determinant of B, it says that determinant of B is equal to 0 and determinant of A is equal to 0 also. Let's prove this one by using the cofactor form. Any row we can choose here. The determinant of, I'm going to find what is the determinant of 2, 3, 1, 3, 1, 8 and 2, 3 and 1 is equal to, by if we use the cofactor method. Cofactor method means we are choosing one of the row. I'm going to choose this row. So 2 times here, let me write the formula, remind the formula, A11 plus A11 plus A11 times plus A12 times C12 plus A13 times C13, it's going to be, which is equal to here 2 times the minus 1 to the power of 1 plus 1 times the cofactor matrix, and the minor, it's going to be for the first row, first column, it's going to be equal to 1, 8, 3, 1. Then plus 3 times minus 1 to the power of 1 plus 2 times the, when you close, this is 3, 8, 2, 1, it's going to be. And the last one, it's going to be equal to 1 times minus 1 to the power of 1 plus 3 times the minor, it's going to be equal to 3, 1, 2, 3. Here, this is going to be equal to 2. This is equal to minus 3. Here, this is equal to 1, it should be. And then here, it's going to be equal to 2 times 1 times 1, it's equal to 1 minus 24. And plus, actually, minus 3 times 3 times 1 minus 8, it's going to be 3 times 1, 3, minus 2 times 8, which is equal to 16. And the last one, it's going to be 1 times 3 times 3, 9, minus 2 times 1 is equal to 2, it has to be. So this is going to be equal to 2 times minus 23. This is minus 3 times minus 13. And this is 1 times here, 1 times 7, it has to be, which is equal to minus 46 plus 39 and plus 7, it has to be. As you see here, the sum it's going to be equal to 0. So determinant of this matrix, since the two rows are identical to each other, it's equal to 0. And you can check also this one by using the same rule, and you're going to see that the determinant is going to be equal to 0. Okay, let's continue with the other property. Here I'm going to use 2 by 2 matrix. Generally we are using 3 by 3 matrix, but to get the transpose and then the matrix determinant of the matrix, it's going to be, because I'm going to get the determinant of 2 of the matrix. The transpose of A, determinant of transpose A is equal to determinant of A also, which means that the determinant of the transpose and then determinant of the A, it's going to be too long for us. So that's why I use 2 by 2 matrix. As you see from the property, we are going to say like this here. This is, if this is A transpose, it's going to be equal to, here rows can be written as columns, row and 1 and minus 1, it has to be. So with respect to this form, here 2 times the determinant of A is going to be equal to 2 minus, there is no need to put parentheses because we don't have another, 2 times minus 1, which is equal to minus 2, 1 times minus 3, it's going to be equal to 1 times 3, it's equal to 3, and minus 3 I have to write here. And the determinant of transpose of A, of course, I didn't complete this one, the result was 5. And 2 times minus 1, which is equal to minus 2 again. And 3 times 1 is equal to 3, minus 3 it should be, and as you see, it's equal to 5. And we can prove the determinant of the transpose is equal to determinant of the A. If you want, you can check also for the 3 by 3 matrix. In the exercises, we are going to have this kind of things. Okay, let's continue with another theorem. Here it says that, and for the n times n matrix, if you multiply by scalar, you have to multiply by only one row or by one column. So when you are multiplying by k, if you don't want to change the result, only you are going to multiply by one row. Here ka11, ka12, and ka13 it's going to be. If you remember, this is different than multiplying the matrix by scalar, because if you're looking for, let's say, 3 times A, then each of the entries must be multiplied by the 3. Here it should be 3 times 0, 3 times 1, and this is the 3A, but this is 3A, but determinant of 3A, it is not equal to, also it's shown in that one, determinant of 3A is not equal to 3 times determinant of A. That's the important part here. Okay, let's continue with this exercise. Here on this exercise, the matrix of A is given, and here the second column multiplied by 2. So we are going to prove that this is the double of, this matrix is the double of the other one, or determinant is double of the other one, the first matrix. And for this one, first we are going to calculate the determinant of the A. Let's calculate the determinant of A. A is equal to, determinant of A is equal to, I'm choosing this row because in this row we have 0, or you can choose the column also, but in this row we have 0, and when you have 0, it's going to be easier for us to calculate. So this is 2 times minus 1 to the power of, this is second row, first column, it's going to be times, when you close second row and first column, the minor, it's going to be equal to 2, 3, 2, 3, and minus 1 and 2. It has to be. Then 0 times minus 1 to the power of something it's going to be, but that's going to be 0. That's why I'm not going to continue to write, not to lose time for that one. And then 1 times, here it's going to be minus 1 to the power of, this is second row, third column, it's going to be second row, third column, times the minor, it's going to be equal to 1, 2, 1, and minus 1. So this part was equal to 0, and this is going to be equal to, since the power is odd, the result is going to be negative, and minus 1 times 2, it's going to be equal to minus 2. Here it is same, the power is odd, so it's going to affect negative, and this is going to be minus 1. So the determinant of A, it's going to be equal to, here, it's going to be equal to minus 2 times 2 times 2 is equal to 4, minus 3, it's going to be 1 times minus 1 times 3, it's going to be minus 3. Then here plus, actually it is minus 1 times, 1 times minus 1 is equal to minus 1, 1 times 2 is equal to, it's going to be equal to 2, so minus 2 it has to be. And then it's equal to minus 2 times, right, minus 2 times 4 plus 3 is 7, minus and minus, and this is minus 1 times minus 3, which is equal to minus 1 times 3, which is equal to minus 14 plus minus 3, this is plus 3, it's going to be, which is equal to minus 11. Okay, let's try to find the determinant of this matrix. What is the determinant of this matrix? If we ask, is equal to, again I'm going to select this row here, and on this row, let's say 2 times, this is the second row, so the powers all they're going to be same, 2 times minus 1 to the power of 2 plus 1 times the determinant of this minor, it's going to be, when you close this 2, 4, 3, and minus 2, and 2 it has to be. Then plus 0 times something it's going to be, I'm not going to write that one. And the last one is 1 times minus 1 to the power of 2 plus 3 times the minor of the matrix, it's going to be 1, 4, and 1 minus 2, it has to be. Okay, so here is, we did in the first operation, this is going to be minus 2, and this is going to be minus 1, and this is 0. So minus 2 times 4 times 2, it's equal to 8, minus 2 times 3, it's equal to minus 6, and here minus 1 times 4 times 1 times minus 2 is equal to minus 2, 1 times 4 is equal to 4, but since we have this, we are subtracting minus 4, it should be here, which is equal to minus 2 times 8 plus 6, which is equal to 14, then minus 2 times 14, minus 1 times minus 6, it's going to be, which is equal to minus 28 plus 6, which is equal to minus 22. Minus 22, if the determinant of A is equal to 2 times minus 11, which is equal to 2 times determinant of A, it should be. So as you see, we multiply only by one row, and we got the same result here. And we are going to continue with this last property. Here it says that when you multiply the matrices, then if you get the determinant, it is same with to get the determinant of the first matrix, then second one, and multiply it. So we are going to prove by using the rule here, we are going to prove that's correct, but we are going to do this one as an exercise. Now I want to solve only this one, Here, determinant of a square, what it is, if determinant of a is equal to 5, if we apply the formula, if determinant a square, we know that that's equal to, or determinant of a square, I can write also like this, determinant of a square is equal to determinant of a times determinant of, I'm sorry about this one, I used the determinant of a square is equal to determinant of a times a, which is equal to determinant of a times determinant of a, and that's equal to 5 times 5 should be equal to 25. This is the last question, and we are going to solve the other questions like exercise in the class.